Hello and welcome to another tutorial session on my YouTube channel. We continue with Northwest Mock 2020 further mathematics, and today we are going to be looking at question 6. The question reads that given that x is small for x to the power 4 and higher powers to be neglected, show that ln of 1 plus sine x is approximately equals to x minus 1 half s squared plus 1 on 6 s cubed. Now the next step is to deduce a corresponding approximation for the ln of 1 minus sine x. Hence, show that cosine of x is equals to negative 1 over 2 s squared, 9 marks. B part says a sequence un is defined by un equals to that. Deduce or determine whether or not un converges, 3 marks. So let's get into the solution. So the first part of the equation, as we have been, want to show that the ln of 1 plus sine x is equals to what? 1 minus s 1 minus, that's x minus a half s squared plus 1 over 6 s cubed. So we begin with this. We are going to use some standard expansions here. We have to recall the following expansion. The ln of 1 plus x, that's a Maclaurin series expansion of ln 1 plus x, is approximately equals to this. This is a power series solution, series expansion of ln 1 plus x. That's a Maclaurin expansion. Now, that's expansion about x0 equals to 0. Now, with that, we also make use of this the Maclaurin's expansion about sine x equals to this, where x is small. Now, having this in mind, let's go now to what it means. Ln of 1 plus sine x, I will simply come to this expansion. Remember, we are ending at x to the power 4, so that all these other terms will be neglected. Same thing here. I will just forget about this part, this x to the power 5, forget about it and any other term. So after that, ln of 1 plus sine x is approximately equal to, I come to this expansion and replace x by what? Sine x. I have that. Now all I need, I have sine x, I need to look for sine x square and sine s cube. Sine s square is simply this sine x, you square it, neglecting higher powers. Since we are neglecting terms in x to the power 4, so from here to the right we neglect it for the other one. So we'll be ending for both expansion, we end at s cube. That's why I ended at s cube, something cube here. So I'll come here and focus on this part. When I square the sign, I'll just take this part. Since I'm neglecting higher powers, I'm going to have in what? X minus 1 on 3 factorial is 6 s cube square. When you square that, we'll be having s square. That's the only term. If you expand everything here normally, you will see that the other powers will be greater, because the next power will be the product of the two, which will x to the power 4, and we are neglecting it. So when you expand it, neglecting higher powers, sine x to the power 2 is just approximately equal to x squared. Now for the sine s to the power 3, similar thing, when you expand this and neglect higher powers, we'll just be having, remember the standard identity to expand something cube, it will be the first thing cube, right? If you multiply, if you expand it normally, you should be able to have that. So we'll be having x cube. When expand this normally and neglect the higher powers, sine x cube is approximately equals to x cube. Now, after having this in mind, we'll now just go and replace in this expansion that we have there. That will give us what we have here. Sine x is what? This neglecting higher powers, x minus 1 on 3 factorial, which is 6, as you can see, x cube. And I'll replace sine x squared by what? X squared. And sine x cube by what? S cube. And you can also go, you must not even do this squaring, because look at it. You are told that when x is so small, so that higher terms, higher powers of x are neglected, trigonometry, sine x is approximately equals to x. So if x is very small, so that the square of it will just be what? X squared. Then similar thing here, sine x is approximately equals to x. Since x is small, is so small that these terms can be neglected, so that this one will just be what? S cube. So that's another way you can look at it. You just come and replace now in this expansion that we have here. And then now when we simplify this and this they are like terms, we can simplify it by multiplying here by 2 and here by 2. Adding the numerator give us 1 on 6 s cube, which is exactly the proof as required. That's the proof of the first part. Now let's go to the other part of the equation that asks us to deduce an approximation for ln 1 minus sine x. We know that we have ln of 1 plus sine x equals to this, and we know that the sine function is an odd function. So if I replace x by negative x, I'll be having, and sine of negative x is negative sine of x, so I just replace x by negative x. So replacing x by negative x, we are going to get the formula, the expansion directly. So replace x by negative x, this one will become, it remain positive, the negative sign stands, and when a negative number is raised to an odd power, the number becomes negative, right? So it will just be what? Negative x cube. I have it there. So that's the deduction that we can make from this. So let's go to the next part of our presentation, which asks us now to do this, to show that you say hence, the word hence has been used. It means that we have to use the previous results and achieve this one. If they use the word hence in the equation and you use your own method to solve, you'll be penalized. At times you don't earn a mark. But when they use the word hence or otherwise, means you have been given liberty to use your own method. So you are at liberty to use your own method. But now that the word hence has been used, we are going to use the previous results as follows. Now we have this first one, I'll call that equation 1. That's the first result that we proved. The other one, I call it the deduction that we made. Now you see that when we add the two equations, we have ln of 1 plus sine x plus ln of 1 minus sine x to be equals to what? When you add these two, will disappear. This one will go negative 1 over 2 x squared plus negative 1 over 2 x squared, just like half plus half, so it will be minus x squared. Now the left hand side can be simplified using the addition law of logarithms. Ln of a plus ln of b is ln of ab, right? So, and when you multiply these two guys here, we say I use the difference of 2 squared, so that will just give me what? Ln of what? 1 minus sine x, all that squared, and this is approximately equals to what you have on the right hand side. Now from here, now we know from trigonometry that 1 minus sine square is what? Cosine square. So we just have ln of what? Cosine square, cosine of x square, approximately equals to what you have on the right hand side. Applying laws of logarithm here, the two can become a coefficient. That will give me 2 ln of cos x, approximately equals to what? negative s squared almost equals to. Now from there, now we divide both sides by 2, it gives us a proof directly as required. So that is the end of that part. So now let's look at the B part of the question. A sequence is defined to be that we have to show to determine whether or not the sequence converges. Remember, this sequence will converge if and only if it has a limit. This is a sequence, not a series, so don't go using some sort of test that I don't know. All you need to do is to evaluate the limit of this sequence. If the limit exists, then the sequence converges to that limit. Okay, now so going like we know that un converges if it has a limit. Now from there, now let's evaluate the limit. Limit of as n tends to infinity, so there's an infinity here, of un is equals to the limit as n tends to infinity of this un. I just copy that. So now what I do is this: you cannot evaluate this limit directly just by observing with your eyes. So to do this, we multiply the numerator and denominator by the conjugate of this. So we just multiply the numerator and denominator by square root of what? N squared plus 8n plus n. Since I have multiplied the numerator and denominator, I have not changed the expression. I have not changed it. So this is exactly the same thing. This is just multiplying by 1. Actually, now the next step we expand this. This time, this when you multiply something in a root times itself, it will just give all what you have inside the root. So that will just give me what I have here, n squared plus 8n. Then now this is the difference of two squares, you guys can see. So minus n squared, and the denominator we have it like that. Now going further to simplify, we will see that n squared minus n squared is 0. So we are left with 8n at the numerator. And at the denominator, we are going to factor out an n square here. When you factor out an n square, this is what you are going to get. We have n squared into 1 plus 8 over n. Because since I factor out n square, I have to divide this 1 by n square. 8n divided by n square will give us 8 over n plus this other n. And then now from there, now when we simplify, square root of n square, normally some people take it as the absolute value of n, which is by definition not bad. But now when we take the square root of n square is exactly n, actually in this case. Reason because we are working with a sequence of positive terms. We are working with a sequence of positive terms. We are evaluating limit at infinity, so n is positive. So this is actually the absolute value of n actually. But since n is positive, then the absolute value of n will be exactly equal to n. So it's important to note that. So the n's can now cancel out uniformly to give us limit as n tends to infinity of 8 divided by square root of 1 plus 8 divided by n plus 1. Now since n is tending to infinity, this quantity becomes, it will approach 0. So the numerator will just remain 8 and the denominator will be what? 1 square root of 1, then now plus this 1. So square root of 1 is 1 plus 1 gives us 2. So at the end of the day, this limit is just what? 8 divided by 2, giving us 4. Since the limit exists, we can conclude that un converges. So this is the end of this presentation. I thank you all for watching. See you guys in my next video. Bye bye. Stay tuned and don't forget to share.